Good morning, sixth graders. So today we are going to be looking at lesson 22, and we're going to be looking specifically at the formula for distance. So we're going to be kind of looking at speed and looking at time, or rate and time, to determine a distance, or using that formula to determine one of those other things. So if we read this first little part, this first little kind of sentence kind of telling us what this formula is, it says, if an object is moving at a constant rate of speed for a certain amount of time, it is possible to detect how far the object went by multiplying the rate and the time. In mathematical language, we say distance equals rate times time. So what that means is if something, say a person, is running or moving at a steady rate, their rate isn't changing, their speed isn't changing for a certain amount of time, say for 5 minutes, 10 minutes, 20 minutes, we can figure out how far they're going to go, what the distance they're going to travel is. We can also use this formula kind of backwards to find the rate or to find the time if we know the other two pieces. So let's take a look at this formula real quick. We're not really going to use this walker and runner part. This would be an activity that we would do if we were together. Unfortunately, we're not, so we're not going to do that activity, but we are going to use the formula that is written here. So we have this formula, distance equals rate times time. When we see this little dot here in the middle, those two dots, that just means multiply, okay? When we start using what are called variables, so these letters, we call them variables because their value can vary. We don't use that multiplication symbol that looks like an X, because then we can get confused with, is that a multiplication symbol or is it a variable? So when we start using our variables like R and T and things like that, we use a dot instead of the X for multiplication. So just keep that in mind, that that's what that means. So, like we said, we can figure out the distance that something has traveled or that someone has traveled if we know their rate and the time. So the rate is something that we've talked about before. We've talked about unit rate. So that would be like something to 1, right? Maybe it's miles per hour or words per minute, things like that. We also said that we can use this same formula to find the rate or to find the time if, say, we know the distance and we know one of the other pieces. So let's pretend that we know, or that we don't know the time. We're going to say we don't know what the time is. So in order to figure out what the time is, we need to kind of move the equal sign. But we can't just move it. That's not something that we're kind of allowed to do in math. That would change things too much. So what we have to do is we have to get rate on the other side of the equal sign. This is where those inverse operations that we've talked about before come really in handy. So remember, the inverse operation is like the opposite operation. It's the operation that undoes the other one, right? So adding undoes subtracting. In our case with multiplication and division are inverse operations. So I'm going to rewrite this over here so I have a little bit more room. So I have distance equals rate times time. So in order to get the rate on the other side of the equal sign, we're going to divide it. So we're going to divide rate by rate. So I'm going to kind of turn it into a fraction. All right, so rate over rate would just equal 1. So that kind of goes away. And then we divide the distance by the rate. So now we know that if we need to find the time, our formula changes just a little bit to distance divided by rate. We can do the same thing if we didn't say that we didn't know the rate. We needed to find what the rate was. We can do that same thing we have distance equals rate times time. We're going to divide by time. Time over time is just going to equal 1. So now we know that the rate is going to equal distance divided by time. So these three equations, these three formulas will be helpful for us. It's all using the same formula, we're just kind of moving things around a little bit. So if we don't know the distance, we multiply the rate and the time. If we don't know the time, we divide the distance by the rate. If we don't know the rate, we divide the distance by the time. So we're using that same formula, we're just kind of using it to our advantage. So let's take a look at the next page. So we have part 1. Chris Johnson ran the 40-yard dash in 4 and 24 hundredths seconds. What is the rate of speed? So we've already kind of talked about how to find the rate if we know the other two parts. So let's kind of fill in our equation with the numbers that we know. So we know the distance. Our distance is 40 yards. Oops. Sorry about that. So we know the distance. He ran 40 yards. We don't know his rate, so we're going to leave the R, but we do know the time. 4 and 24 hundredths seconds. So if we remember, back to what we were just talking about, we can divide both sides by the thing that we do know. So we're going to divide by 4 and 24 hundredths. So we know that that'll get rid of our 4 and 24 hundredths. And we're going to divide our 40 yards to find our rate. So go ahead and divide that out. 40 yards divided by 4 and 24 seconds. This would be a great time to pause the video, and then you can pop back on to check your answer. So as you can see, I kind of changed the formula a little bit so that it's a little bit easier to read it, to our rate equals distance divided by time. So rate equals distance divided by time. The rate is going to equal 40 yards divided by 4 and 24 hundredths seconds. And like the instructions say, we're going to round the answer to the nearest hundredth. So the rate is equal to about 9 and 43 hundredths yards per second. So when we see that like something slash something, so like miles slash hour or yards slash second, that just kind of is a shorthand way of writing yards per second or miles per hour or whatever your units are. Let's take a look at part 2. So part 2 says, in lesson 21, we converted units of measure using unit rates. If the runner were able to run at a constant rate, how many yards would he run in an hour? This problem can be solved by breaking down into 2 steps. And it says to work with a partner, but we're going to work on it together. So we're going to use that same number, that 9 and 43 hundredths yards per second, as our rate from part 1. So A says, how many yards would he run in 1 minute? So if he's running 9 and 43 hundredths yards in a second, then we need to know how much he runs in a minute. Well, how many seconds are in a minute? There's 60 seconds in a minute. So we are going to multiply, right, because we have to find our distance. So our distance equals rate times time. We don't know our distance, but we know our rate. So our rate is 9 and 43 hundredths yards per second times the time, 60 seconds. So we're multiplying 9 and 43 hundredths times 60. Go ahead and pause the video, multiply that out, pop back on to check your answer. So when we multiply yards per second times seconds, the seconds kind of cancel each other out. So I'm going to cross both of those out. So our answer is just going to be in yards. So I'm going to multiply 9 and 43 hundredths times 60, and I get 565 and 8 tenths yards. So in 1 minute, that's how far he runs. You could also have 565 and 80 hundredths yards or 8 tenths. Either one is fine. So in part B, we have how many yards would he run in 1 hour? Well, we're going to use that same formula, that distance equals rate times time, because we know our rate and we know our time. We just don't know our distance. So we know that he runs 9 at a rate of 9 and 43 hundredths yards per second, or actually we're gonna make it a little bit easier. We're gonna use that 565 number. So we know he runs 565 and 8 tenths yards per minute. And we know that there are 60 minutes in an hour. Again, our minutes cancel each other out, and we're going to end up with yards per hour. Go ahead and multiply that out and pop back on to check your answer. All right, so we're going to multiply those two numbers together, and we get this number, 33,948 yards per hour. That's a lot. It's very far. So we completed this problem in 2 different steps, right? We took 2 steps to figure out how many yards he runs in an hour at this rate. We are able to complete this problem in 1 step. We can multiply yards per second by seconds per minute, then by minutes per hour. So we can kind of do this whole thing all at once. So we can multiply our initial rate, right, of 9 and 43 hundredths yards per second times 60 seconds per minute times 60 minutes per hour. So our seconds cancel each other out, and then our minutes cancel each other out. And then we multiply 9 and 43 hundredths times 60 times 60. And we end up with that same number. So these are both valid ways to solve this problem. In my opinion, I prefer to solve it in 2 steps because I'd rather multiply 2 numbers than 2 numbers rather than multiply 3 numbers together. So it's up to you. However you would prefer to do that. And then we have part 3. Part 3 is asking how many miles did the runner travel in that hour? So we know that he traveled 33,948 yards in an hour, but we need to know we want to know how many miles he traveled. Well, then we need to know how many yards are in a mile. So using that same formula that we've been using, we have our yards per hour times our miles over yards, or how many yards are in our mile. So in 1 yard, there are 1,760, or sorry, in 1 mile, there are 1,760 miles. So our yards cancel each other out, and we're left with miles per hour. We are going to, instead of multiplying these, we need to divide them, and we end up with 19 3/10 miles per hour. Oh, sorry, this is supposed to say, it's supposed to be division. Sorry about that. Alrighty, so let's keep going. We have a little bit more. We only have one more page. So our next problem says, I drove my car on cruise control at 65 miles per hour for 3 hours without stopping. How far did I go? So I want you to pause here, work that problem out, and then pop back on to see, to get your answer. If you get stuck, pop back in to get some help, and then keep going. Alrighty, so we have this kind of framed out equation. Distance equals blank miles per hour times blank hours. So our problem says that we drove the car on cruise control at 65 miles per hour. So our rate is at 65 miles per hour. And they drove for 3 hours without stopping. We need to find the distance. Well, our hours cancel each other out, so we're left with just miles. So we are just multiplying 65 times 3 to find how many miles. We multiply that out. We get 195 miles. So at that constant rate of 65 miles per hour for 3 hours, you'd go 195 miles. All right, so for exercise 2, it says, on the road trip, the speed limit changed to 50 miles per hour in a construction zone. Traffic moved along at a constant rate, 50 miles per hour, and it took me 15 minutes, or 0.25 hours, or 25 hundredths of an hour, to get through that zone. What was the distance of the construction zone? It says to round your response to the nearest hundredth of a mile. Go ahead and pause here and solve that problem. Pop back on to check your answer. All right, so we have our kind of equation frame. Our distance equals blank miles per hour times blank hours. So it says that on the road trip, the speed limit changed to 50 miles per hour. So our rate dropped down to 50 miles per hour. And it took 25 hundredths of an hour to get through this construction zone. So our hours cancel out. We're left with just miles. And we're going to multiply 50 times 25 hundredths. So we multiply. Then we have 2 digits behind our decimal point, so that means our decimal is going to move 2 places over. And we're left with our distance traveled is 12 and 5/10 miles, or 12.5 miles. Alrighty. So let's take a look really quick at your independent practice. Your independent practice looks like this. There's only 4 problems. So you have question 1, if Adam's plane traveled at a constant speed of 375 miles per hour for 6 hours, how far did the plane travel? Number 2, a Salt March harvest mouse ran a 360 centimeter race in 9 seconds. How fast did it run? Number 3, the Sopwith Camel was a British First World War single-seat biplane fighter plane traveling at its top speed of 110 miles per hour in one direction for 2.5 hours. How far did the plane travel? And number 4, banana slugs can move at 17 centimeters per minute. If a banana slug travels for 5 hours, how far will it travel? So remember to use that formula of distance equals rate times time. And remember our kind of inverse operations to find the other pieces. So if you have to find rate or if you have to find the time. If you get stuck at all, please let me know. I am here and I'm happy to help. Or you can contact Miss Sally and she is also here and happy to help. I hope you have a fantastic rest of your day, and I will see you tomorrow, sixth graders.